This is not how you make copies. You have this list assigned to X, then you want to make a copy, so you assigned X to Y, then you append the value 10 to Y. You expect that only Y will change, but actually X will also change because you didn't make a copy of X, you just get the reference of the previous list assigned to X and Y at the same time. To make a copy, you have a lot of options. You can call copy.copy with an X as an argument for shallow copy. You can see that it works. We have two different lists. You can call also deep copy for a deep copy. You can also call the copy method of the object if it exists. Here it exists and it works. You can also use slicing if you have a sequence. Here we have X is a list, a sequence, so you can use slicing and it also worked. Mutable or not mutable? That's the actual question. We have X equal 5, which is an integer, and the integers are immutable. We have y equal x equal x plus 1. You may expect, since we've seen previously, that the value of x and y will be the same, but wrong. They are different. Why? Since x is an immutable, when we wrote x equal x plus 1, we created a new object. To be sure of that, we are going to print the ID of x after the first assignment and its ID after the second assignment, and we will see that they have different values. They mutate you and return nothing. Let me explain. We have this assignment x equal the list 1 to 153, y equal x dot sort. I'm calling the sort method on the list x. After printing x and y, we can see that x is sorted, but y has nothing. Sorted the actual values of the list x, but it returned none. That's the convention in Python. Most of the function and methods that mutate will return none. Now, if I use another sorting method, we have the same list x. We call sorted on x. We print x and y. You can see that x didn't change, but y was changed since sorted returned a value. It didn't change or mutate x, but it returned a value. These operators are shapeshifters, and this is why. Let's say I have a list of 4 and 5 elements. I will assign it to another variable, c. This augmented assignment. A list equal a list plus another list, 1, 2, 3. In this case, this operator mutated my list. Now, if I print c and print our new list, we can see that they have the same values. Now we can apply the same operator on a non-immutable object. So in this case, it cannot mutate our tuple. So what it will do, it will create another object, as we can see here, that it didn't mutate the previous values of tuple. To be sure, we can print the ID of the first tuple before and after assignment and do the same for the list. You can see here that the ID of the list remained the same, but for the tuple we have two different values. This is not an operator, this is a separator. Let's say I have this statement, print the string A in B, comma, string A, comma. Here is a simple separator because this is the same as if we wrote print A in B between parentheses, then A. Sometimes it's like this, sometimes it's like that. Let's say we have this function that has these two parameters, a and b. We assign to a new value. To b, we also increment it by 1 and return the new values. If we define these two arguments, x and y, with the string and integer value, we call the function. We can see that the values didn't change. Now, if we define another function that has a list as a parameter, and we assign to the first argument string value and the second argument gets implemented, we define this args list to pass it as a parameter, and we call the function, then we print the values of the last parameter. We can see that the parameter changed. This is going to confuse you. If we run this code, we will not get what you expect. The rest of the integer division of minus 190 by 12, it's not minus 10, but it's actually 2. The same thing, but the integer division. If I have minus 190 divided by 12, we'll have also minus 16 instead of minus 15, because it got the floor value, and the floor value is minus 16. It's an object, but yeah, if you want to print one dot class, knowing dot one, it's an object of type integer, it will generate an error. So to avoid this problem, since it will consider the dot as a decimal letter. So this is why for this particular case you can add the space before the dot, so it returns the expected result. You can also, instead of space, use parentheses around your integer value to know its class. Its shape shifts again. We have a tuple equal to 1, 2. We've seen that we could use the augmented operator assignment with tuples, but in this case it will not work and it will generate an error, because this time we are trying to modify internal value of the tuple. You have to do it that way. Let's say that you have this class A with these two methods. The first one starts with 2 leading underscores and it's called 1. The second one is a regular method called 2. The first one is actually a private method inside the class itself. You can call it as any other method. Here in the 2 methods we are calling self dot and then the leading underscores and the name of the method. But outside of the class you have to do something different. You have to add something. You are going to add the name of the class, then the 2 trailing underscores. By even when you create an instance of a class, if you want to call that method outside the class, you have to specify the name of the class before calling it. If I do so, you can see that there is no error, but if I remove the trailing underscore and the name of the class, you can see that it generated an error. If you have any question regarding one of the points discussed in this video, just let me know in the comments below. Bye.